Hey folks, welcome back to Walter's Aircraft Works. It's August 28th, 2017. Out in the shop here today trying to get a little something done. Still on work stoppage with our conversion here, our EV conversion on our RX7 due to lack of batteries. Still trying to figure out how to solve that problem. Hopefully we'll be solving that soon and getting back to it. But there's still a few other things that need to be attended to on this car. One is the headlights. Actually, the headlight retract mechanism. I have one out over on the bench. We'll look at it here in a minute. But just a little bit of poking around I did on the internet. The parts for these retract motors are apparently unavailable. So means we're going to have to find alternate means of repairing them. And I think I've got a plan. Thought maybe other Mazda owners would be interested in how I'm going to solve this problem. So let's go back over to the bench and take a look at it, and I'll show you what I'm up to. Okay guys, this is what we're looking at. This is the retract motor or extension retract motor for the right hand headlight assembly, and this is the problem. These are arms, these articulating arms. There's two of them. There's a short one here and a long one. Let me turn you a little bit so you can see the short one, which connects to the headlight bucket and then through this over center mechanism, and then the longer one which takes you up to the motor and the crank on the motor. Well, these nylon or plastic bearing ends are what tend to wear out, and they're difficult to replace or difficult to find. I couldn't find any replacement, just plastic pieces on the internet. I did find it was either the long arms or the short arms, one or the other, not both, available, but they were rather expensive. And to me, it doesn't really solve the problem. It just kind of, well, I guess you could consider it solving the problem, since it's, what, 35-year-old cars, so replace them and maybe they last another 35 years. I don't know, but either way, I couldn't find both arms, so it wasn't a solution. I did see links somewhere on one of the threads that I was looking at for somebody that was 3D printing these plastic pieces to re-snap into these arms. And that would have been, that's a neat idea. I would have gladly paid for those, but the link is broken, doesn't work, it's not up anymore, so no longer available. So how do I fix this problem? Well, I'm going to replace them with a rod end. The parts are readily available and reasonably priced. They'll, machined right or applied right. They'll last forever. Infinitely adjustable. I think it's a good option. Here's a rod end that I have. It's actually an old tractor part that I just dug out from my scrap pile in the back to kind of give you an idea what I'm talking about. These are kind of inexpensive stamped steel rod ends. Not really what I'm going to buy, but kind of, and actually a little bit too big for what I want to do with them. But this is what I'm talking about using. I'll wind up having to drill off these balls here. They're swedged onto the plate. There's one swedged here. There's one swedged on the crank for the motor. Another one swedged down here on this articulating arm, or whatever you want to call this triangle shaped piece that kind of moves back and forth. And then there's one swedged on the headline bucket as well. I'll have to drill those out and then machine some kind of hat bushing or washer to fill that hole, and then give us a place to bolt the bolt going through these rod ends. Now, the ones I'm looking at buying are not exactly like this. They are, well, let me show you the picture in the Car McMaster catalog. Okay, so here they are, the carbon fiber reinforced race ball joint rod ends. did I pick this particular one? You can see there's lots of them available. There's probably 15 different types. And why did I pick this one? Well, they're self-lubricating basically. They don't really need much lubrication, and the reality of it is they're cheap. They're $5.11 each. So that makes it pretty reasonable to buy 8 of them. So I'll get, like I said, 8 of these, the male ones, and I'll also buy, let's see, the coupling or the right hand threaded connecting rod. It's just a really aluminum tube that's threaded on the inside. We could make this easy enough on the lathe, but why when I can buy a 18, let's see where it is, right here, 18-inch length of it for $8.50. So hardly worth messing with the lathe when I can buy 18 inches of it for that kind of money. And we'll just, since it's all right hand thread, and the rod ends that I'm going to buy are going to be right hand thread as well. So cut it to length, thread it in each end, adjust it to the length that we need for the links, and then the only real labor we're going to have is machining the hat bushings to fill those holes on the swedges that we remove from these balls here. Okay, so what's the damage here for replacing all 4 links? Well, based on my very old Car McMaster catalog, it's right about 49 and a half bucks. Well, maybe a few bucks more than that by the time we get it adjusted for reality here. But shouldn't be any more than what, 65 bucks I would guess, which is really not a bad price compared to what I was seeing on the internet. Like I was saying earlier, now that I think about it a little more, I think it was these long links that were not available, because that's the one I really needed to replace, was this long one here. The short ones were, like I said, available for about $100. So if I had to buy all 4 of them at $400, if they were available, that'd be pretty pricey. So if we can get this thing fixed with a repair that would not, as far as I can tell, ever wear out, for under 70 bucks, I think we'll be in pretty good shape. All right, I'm going to order these parts, and we'll get started here as soon as they come in. All right, well, we're waiting for the parts to come in. I thought maybe I would take some of this apart and just start working on drilling out these wedges to get ready for the rod ends. So, well, let's talk a little bit about how I got the motor assembly out of the car. It was pretty easy. There was 3 bolts holding the motor assembly in, at least at the base here, and then 1 here on this flange as well. I'll take you back over to the car. I'll show you where those are, and maybe I'll roll up the other one so you can see. We'll have 1 out and 1 in, and so let me get back over to the car. Okay, from this angle on the left-hand motor, we can see, well, kind of where the bolts are. Here's one that I had to take out, and then there's one on the back side that you can't see, and one at the bottom there that you might be able to see, and then one on the bottom flange here that has to come out as well. That'll take the assembly loose, and then you really don't have to take the headlight bucket off to get the motor out. You just need to pop this link loose right here, but I went ahead and took the right hand bucket loose just to get to the back side of it, because like I said, I'm planning on drilling this out and attaching our rod end right here, and I'll have to machine, like I said, some kind of hat bushing here, or hat washer on the back side of it to take up the gap. These are, it's hard to tell. Let me spin around here. It's about three. I believe the shaft going through here, I'm sure it's some kind of metric dimension, but about 3/8 of an inch in diameter. So the rod ends that I'm going to order are 1/4 inch bolts going through them. We're going to have to fill that gap with a hat bushing. You'll see what I'm talking about when we start machining those parts. But nevertheless, this is going to have to come out. This is going to have to be drilled out of here because it's wedged in there, just stamped in there. So that's the reason why I took the headlight bucket out. And it's pretty easy to take off as well. Just go back over here to the left hand side. Pulled up this piece of rubber here and removed this bolt, and then there's one more down inside right there. And then the whole headlight assembly will come up. And easy to flip over, and then we'll be able to get access to this joint right here. Now, for some reason, Mazda didn't feel it necessary to put any kind of disconnect into the 3 wires that run out here to the headlight assembly. And I could probably disassemble this headlight bucket and take the wires loose from the back of the lamp and get it loose and be able to take it over there on the bench. And I might do that yet, depending on how hard these are to drill out. But right now I'm just going to leave it here protected on top of the car here. Now the motor assembly was pretty easy to disconnect. It was just really this 4-way connector here, and then the headlight, or the motor, the retract motor, came right out, and as you know, went over to the bench. Oh boy. Okay, now that we've got it out, let's take it apart here. At least let's take this triangular shaped piece off so we can start working on these 2 swedges here. And then the arm, of course, will be pretty easy. One 10mm nut here should relieve it from the motor. And then the last swedge for the last joint we need to talk about, or we already did talk about, is the one over there on the headlight assembly. So we disconnect the link here. Now we need to get this joint loose here. I've already broke this nut loose. It really wasn't difficult at all. Took me a little bit of looking at this thing to figure out exactly how it came apart, because we have a snap ring in the back here. Let me see if I can get you a look at that. Through this access hole, there's a snap ring. So my pliers, I've got several different kinds of pliers, but the best one that seemed to work the best. Alright, another kitty disruption there. But my snap ring pliers that seemed to work the best were these bent over ones here, 90 degrees. And they fit in here fairly well. See if I can do this. Alright, so snap ring out. Hopefully didn't distort that too bad. And then I had to flip it over, break the nut loose, take the nut off. And this is a kind of a strange design. I'm not sure why they did it this way, but I guess it's worked for 35 years. Can't complain about that. Kind of a neat shaft that's got several steps in it. And it's quite a bit of machining work just to make a pivot point here. Let me see if I can get it in view there. So I didn't spend a whole lot of time machining that part there, or at least making it real smooth, but it doesn't really matter. That's not what rides in the bushing. And it's a solid bushing going all the way through, oil light, or probably oil light, some kind of bronze bushing. So it's still really tight. Doesn't have much play in it. I guess it doesn't really see much abuse, so it is pretty dry. So before we put it back together, we'll get it soaked in oil again. Make sure the oil light is nice and saturated. So I guess if you kind of break it down, the reason why they did what they did was the axle here is put through this ear and held in place with these flats they milled on the shaft to keep it from rotating, so it wouldn't lock up between the bushing and the axle. So I'm not sure why they use the snap ring. That seems kind of repetitive or overkill, but hey, it's worked. Well, I don't see any reason why they needed the snap ring in there. Once the axle goes in and then gets tightened down with a nut, it can't go anywhere. So maybe an assembly thing, who knows. Alright, so that's out, and we'll clean these parts up and get to drilling, I guess. Well, shoot, while we're at it, we might as well take this one off too. So let me get a 10 millimeter wrench here. Alright, nothing fancy about that. No backwards threads. I'm sure this has got a flat milled in it to keep it from spinning. A shoulder, looks like shoulder and 2 flats. Now, hold on a second. Let me take a little better look at it. Alright, after further review, there is not a flat milled in the side of it. They're going to make it a little bit tricky on us. It's actually a knurled edge with a straight knurling to index the arm to the shaft. So I'm going to try to be real careful here. I did pop it off and then popped it right back on in the same position, because I'm going to try to index this. I'm going to scribe it so we get it back on in the same position. Alright, I don't know how well you're going to be able to see that, but I took my my mechanics tattooer here and scribed a line between the arm and the output shaft there to help us re-index it. You know, I look at the other side, and you know, if we get this a tooth off or so, it's not going to be horrible to have to readjust this thing. It's, you know, it's easily accessible, so hopefully we got it close here, and it won't be too big of a deal to readjust it if we're off a tooth or so. Okay, so here's what the problem is. This is what's happening. I think why the other end of this same link failed was, you can see that there's a plastic retention ring that holds this inner portion in, which is actually the part that does the work. But this one's failed as well. Looks like about a third of it has, well, actually more like a half of it. It's failed all the way around to here. So once it gives up completely, let's see if I can knock it out of there. Now it's going to be pretty stubborn. There it goes. Oh, pretty brittle. Just a tiny piece left now. Wow. Stuff is hard and brittle. But once it fails completely, then it just falls out of there. Well, that part right there is done. Alright, so that's that. Now these pieces are actually built a little bit different. They don't have that retention ring in them. They're actually riveted on there. So this is probably a better design. Look at that. The balls are a little bit different dimensions. You got big ones and small ones. Alright. Well, I can see where this is a better deal than these bigger ones. But either way, I'm going to replace all 8 of them while I'm at it. So let me get these cleaned up, and we'll press on from there. Alright, if you're a Mazda purist, you better look away, because I've defiled another Mazda part. Here it is. I didn't drill out these swedged on balls. I wound up chucking them up in the mill and then just milling off the shop end or the swedged end of the ball itself. I thought maybe that would help save the kind of the integrity of this piece. And you can see I got a little bit deep there with the mill, but you know, I don't know that it was any easier to do it this way than it was to drill it. The one that was connected to the headlight assembly, I wound up drilling it, and it came out a lot easier than these did. I had to put, well, once I milled the shop end off, or the swedged end off, I had to put it in the press and press them out, and it did deform this plate just a little bit. I had to kind of flatten it back out again. So if I had to do it over again, or when I do it over again on the left hand side, I think I'll just drill them out. I think that's the easiest way to do it. All right, so next is hat bushings, and we'll get to that right now. Okay, there they are. They're all done. I created 8 of these step bushings, or T-nuts probably is the best thing to call them, but as you can see, they just fit in the brackets here. And then I think at least 6 of these I'll braze in, the two that go in here, as well as the one in the arm that comes off the motor, and the other 2 that go in the headlight bucket, which are these 2 right here. I machine those, or turn them with a little bit of a tighter tolerance on them. They're not quite a press fit, or not quite an interference fit, but pretty tight. So I'll probably just clean them up and Loctite them in. They'll be you know, held in place with pressure. So if you imagine this is the back of the ear that's on the back of the headlight bucket, they'll go in, and then there'll be a washer, the rod end, and then the bolt will hold it all together, so it won't be able to go anywhere. So that's it. It took me a little bit longer to get them done than I thought, because apparently I can't read a digital vernier caliper anymore, and I messed up the tolerances on these T-nuts several times. Had to redo them a couple of times. Actually, one rolled underneath the lathe, and I couldn't retrieve it, so I had to make another one because I lost it. But all right, so next thing is we got to get the rod ends in, and the rod, and then we'll be able to put this thing together. Well, bam, there they are. All you got to do is say it and they appear. Well, not quite that easy, but well, in today's society, it's not too much different than that. Order them, and they show up in your door, at your door, in just a couple of days. We've got it pretty good, don't we? And I also realized that I probably misspoke earlier in the video, and I think I called these people Car McMaster, and it's actually McMaster Car. I'm sure McMaster might be upset at me for putting Mr. Carr's name first, but it's been quite a while since I've done any business with these people. The parts are here, and much to my surprise, the rod ends were actually cheaper when I ordered them than what they showed in the catalog. The rod was more expensive by a few bucks, probably close to $10, but all in all, the net taxes and all, about 47 bucks. So it'll be a pretty good deal. We're going to fix our bad links here for $47 and a few hours of our time. Not a bad deal. All right, so next is determining the right length to cut these rods. We need 2 short ones and 2 long ones. Trying to figure out whether I'm going to make a rig block or just measure them and cut them, and exactly where I want these. Let's see, let me get one out here. That's the part number on them. All right, this is what came on the, wasn't much on the rod itself. Let me get one of these out. All right, yeah, you just thread this in the end here, and typically you would have a jam nut on here, You'll thread the other rod end in the other end, have a jam nut on it. That'll keep things tight and from pivoting back and forth. I didn't order any jam nuts. I didn't really see them available there in car. I'm sure they are, or McMaster car. Let me get it right. But I do have some in my other shop that I might have to fetch if we need them. But still trying to figure out whether I'm going to do that or run them in all the way or Loctite them in. But right now what I need to do is figure out how long they need to be, and then we'll go from there. All right, I calculated the length of these by just measuring the holes and then measuring the distance between this edge and then adding the two of them together. So you know, not rocket surgery here, but the diameter of the hole plus this dimension should give you, or will give you, center to center here. And I did that on both. It was a little more difficult with this one because it still has the plastic clips in, and I don't want to take those out, so I didn't really want to destroy them. But anyways, the dimensions were, on the long one it was 5 inches, almost 6 inches on the long one here. Well, there it is, I wrote it on there, but 5.968, and then the short one was 4 inches and 135 thousandths. So then I made this gauge block here, just put it in the mill and drilled and tapped these holes. And you know, from this hole to this one is the long dimension, and from this one to this one is the short dimension. So then it's just a matter of cutting the tube to the right length. Well, there's where the next hiccup is. I should have known when I picked this up after it got delivered that it wasn't a tube. I knew there was some mass to it, some weight to it. So turns out this thing was a 24-inch rod and was drilled and tapped on each end, but is still solid in the center. And I don't know if I didn't read the description properly or I assumed it was going to be tapped all the way through. Well, not the end of the world. I did cut the length of the piece that I needed and use one end that was already tapped, and then just drilled and tapped the other end, and this is what we wound up with. This is what I wanted. So you know, I can adjust the length of these. I have this cut pretty close to the right length, so these rod ends thread in there nice and tight, and then I can still start these bolts in here so it's the right length. It still twists, so there's no binding there. That one should be pretty close to perfect. So one more short rod and then 2 long rods, and we'll be done with this little operation here. So let's see, maybe I'll take you back over to the lathe. I mean, this isn't a complicated operation. I don't know if I need to film it, but you know, basically I'm just using the lathe to part it off, and then drilling in one end of it, running the tap in deep enough so the rod end threads all the way in there, and that's it. You know, like I said, it's not difficult, but that's what I'm doing. All right, new day, another opportunity to screw up here again in the workshop. Yesterday I certainly did my share of just that, screwing up. I broke at least 3 drill bits trying to drill the holes in the end of these shafts. Not sure what was going on, but I just couldn't make it work. So take another swing at it today. I actually, when I went to the store to buy some more number 3 drill bits, I found this aluminum stock, and I got thinking about it, thinking, hey, this is a pretty good idea. I'll make these shafts out of aluminum. It'll be easier to drill, easier to tap, and I think I can do some kind of neat effects on the end here. Well, we'll see if it works out, but may try to powder coat these and maybe turn the ends to back to raw aluminum there, just to make kind of a neat effect on them. We're going to get back at it here. Same process though. I'm going to cut these to length. I'll cut them on the lathe with the parting tool, and then drill and tap the ends, and that all should be good. Should go a lot easier with this aluminum. Let's give this a whirl. All right, the machining of the aluminum worked a lot better than the steel did. It was easy to drill and tap, and then I shot a little bit of translucent blue powder coat on them, and then put them back in the lathe gently, and just put a chamfer on the edge. Not really any functionality to that, just thought it would look kind of neat with a polished edge on it. So now it's some assembly. The motor assembly, I did just clean up a little bit. I didn't disassemble it. I just knocked the the grime off from it, and then kind of touched it up with some paint and a little bit of a clear coat on it too, to give it a little bit of corrosion protection. It's not perfect, but it looks a lot better. And there was a couple, the screws here were a little bit rusty, and a little bit of corrosion on this aluminum case here. Nothing too severe, just some light external surface corrosion on it. So hopefully that clear coat will help protect against it, or keep it protected for another 35 years. These pieces also powder coated, and I've cleaned that bushing out, or I got a little bit of overspray in it and cleaned it out, and then I've re-lubricated it, that oil light bushing, so it should be in good shape too. So I'm going to put it back together and rig these tubes. We'll just thread them together here Excuse my my beat up hands. I was doing a little bit of yard work and had a twig or a branch get away from me. So we'll just thread these in and put them on our jig block here. And I'll probably put a little bit of Loctite on them. But basically that'll be just like this. Bolted there and then adjusted. You can see it's a little bit, well, see a little bit too long here. So we'll run this in a little bit, another turn, get that rod end still just a wee bit long. There we go. Alright, so that should be the right length. I think I will reassemble these with a little bit of Loctite on the ends here, and that should be good. Okay, I got everything put back in the car, and it fit really nice. A little disappointed in the powder coating. I think it's getting old. I've had it for many years, and it's just not very durable. I thought that's what powder coating was all about. It was supposed to be durable, but you can see I nicked it a couple of times putting it in the car. I think when I do the left side, I'll be able to install it a little easier. You learn tricks as you go, and I certainly did by installing this one, so it should be a little bit cleaner on the left hand side. And what I'll do is I'll try to film that whole process and then just fast forward you through it, so it doesn't bore you to death, but you'll get to see the whole process. But let me run it. I'll run them up and down a couple of times and you can see the mechanism work. Real happy with the way it articulates. I think it's going to last forever, and won't have any issues out of it anymore. Okay, let's fast forward through the conversion on this left hand side. I'll just narrate as we go through the process. I'm just cranking up the left hand bucket there so I can get to the bottom of it to get to the attach bolt. I am going to remove the bucket, disconnecting the electrical connector there, and then removing the 3 screws that hold the bucket into the car. Pretty easy to get to, 10 millimeter. Zip those out, remove the actuating arm off the bottom of the headlight bucket, and pull the bucket off the car, just kind of lay it to the side. Next thing we'll do is remove the 3 10 millimeter bolts that hold the motor assembly to the car. There's 3 bolts and 1 nut. Those are also very easy to get to. Once the actuator assembly was removed and over on the bench, I got to work taking the actuator arms off. Just remove those with a flat-bladed screwdriver, and take a little bit of pressure to get them loose, but they do pop off. 10 millimeter nut. Actually, I guess I take the pivot pin loose first. That's a 14 millimeter wrench. It was a little bit corroded, so it took a little bit of work to get it removed. Just pushing the pin out. Next will be the 10 millimeter nut that holds the arm on the motor. And I scribed index the arm to the shaft of the motor so I could put it back in the same place. This is drilling the ball ends off the end. This actually happens to be the arm for the motor. I give you dimensions there for the drill bits that I used. I used a countersink to just take the remnants of the shop end off, so the swedge would come right out of the arm. Same deal with the two balls that are attached to the over center arm. Same process. Drill them out, countersink to take the rest of the shop end off, and they come right out. Use the same process for the headlight bucket. I just had to use a hand drill instead of the mill, but really the same process. Just drill it in the center, get it fairly deep, so then you can use the countersink to finish off that swedge. And, with a pair of pliers, I was able to twist that ball right out of there. Alright, into the old new parts maker there, the bead blaster. Get them cleaned up so I can go over to the welding table, braze those threaded inserts in. Just a real light braze. Really, they're only braze just to hold the insert in so it doesn't fall out once you get the rod end attached. There's no place for it to go, so really don't have to put a lot of heat to it. Same process on the arm for the motor. The second insert on the over center arm. Got to kind of pay attention to which side of the arm those inserts go into. You can certainly make a mistake and put those in backwards. Back into the bead blaster for a cleanup, and I'll blow them off the air hose and wash them off, and over to the powder coat machine. This is a cheap Eastwood powder coat machine. I've been using it for years. simple toaster oven in my workshop there to bake them on until it glosses out, or in the oven until it glosses out, and then a cool down period for, it's about 150 degrees for about 15 minutes. Just a quick cleanup of the motor assembly. Little acetone there. I got the big chunks off with a wire brush, and then some acetone to clean it up. And a real quick shot of paint just to clean it up, make it look a little better, and keep the corrosion off from it. Some more oil for the oil light bushing. This is a reassembly, of course. So with the pivot pin back in, washer, nut, tighten back up. That over center arm could be installed backwards as well, so pay attention to which direction it goes in. And I just scraped the powder coat out of the bevel and inside of that arm so it would seat well to the shaft of the motor. Installing the arms, I had to use a couple of washers for spacers. I believe it's actually on the longer arm for that bolt that I'm installing now. If that bolt was to stick out too far, it would rub on the inside of the longer arm. Yeah, here it shows me sticking the washers on. Spacers. Have to washer underneath the head of that bolt just to keep it from interfering with the bolts that hold the motor on the bracket there. Alright, reinstalling the motor. Like I said, there was 3 bolts, 3 10mm bolts, and a 10mm nut that hold it in. Went in real easy. Lined up well. I just walked off and got a little anti-seize compound because that nut had a little bit of corrosion in it. Alright, coming up is the trickiest part of the operation here. Trying to attach that rod to the back of the headlight bucket. Remember the stock configuration, you just had to reach in there with a screwdriver and pop that arm off. But now I actually got to get in there and install a bolt. It wasn't extremely difficult, but a little bit tricky. You see I added a little bit of red Loctite to that T-nut there, and it's going to be bolt, rod end, large washer, and then the bolt will thread into the insert or the T-nut. That large washer will help hold that T-nut into the bracket on the headlight bucket. Alright, once the bolt's installed, you can flip the headlight bucket around, put it into place, and then install the 3 bolts, the 3 10mm bolts that hold the headlight bucket on. All right, that's about it. Just spinning it back down to make sure it fits well and the body lines line up properly. And there's no rubbing, no chafing, installing the wire loom back where it needs to go, and hooking it back up. Here's an ops check. It worked great. All right, guys, one more project in the can here. Got it all finished up and real happy with it. I like the way it turned out. Took a little bit longer than I expected it to, but they always do. Expense-wise, pretty reasonably priced. The rod ends, I think, were $2.50, $3 a piece, and wound up using that aluminum rod from Home Depot. I think it was about $6. Wasted a little bit of money buying that steel rod from Car McMaster, but that's all right. Live and learn, huh? You know, these longer links may have been available someplace on the internet. I certainly couldn't find them, and I'm glad I didn't, because I like the way the project turned out. I think it's going to last for a long time, if not forever. And I didn't have a whole lot of money in it. A couple days worth of labor, you know, here and there, on and off. You know, filming drags things out a little bit. I think it's an easy weekend project if somebody wants to tackle it on their car. Get the materials together during the week, you know, maybe one long day on the weekend. You know, hey, people probably work faster than me, so maybe they can knock it out in just a couple hours. But it wasn't all that difficult, and sure was rewarding, because the results are good. Hey, this is kind of a standalone project. I think there's people with RX7s out there that that'll want to see this. You know, I kind of tie it into my my EV project. I think it's you know, it's a standalone deal. If somebody's got a standard rotary engine RX7 and having problems finding replacement for these links, it's a good solution for them. I think it is, anyways. So if you're here watching the video because of the headlights, hey, check out the EV project. If you're just fixing your headlight links, then good luck with that as well. Thanks for watching, folks. I'm still working on trying to find some batteries for the EV, and hopefully you'll be able to get that solved fairly soon and get back to work on the conversion. All right, that about wraps it up. So till next time, get off the couch and get something done.